In this video, let's see an IIT JEE numerical problem which was based on the topic of determinants and was asked in the year 1993 for 2 marks. Now we already know what is determinant and we have seen few numerical problems. This video is in succession to the previous problems. Let's see what the question has to say and let's get started with the solution. The question says for positive numbers x, y, z, the value of the determinant, this big determinant is equal to what? Now I already know that this is a question which didn't have options, it was asked in the year 1993, so I have to solve it. And I know that it is based on something called as logarithmic function, and you already know that what is the value of log m to the base n? It is nothing but equal to log m upon log n to some common base, maybe it is 10 if it is not mentioned, or any other base. Similarly, here if you see, it is log y to the base x, log z to the base x, log x to the base y, log z to the base y, and so on. So we can actually simplify this question a bit and we can modify this question a bit. This question becomes what? It becomes 1, it becomes log y upon log x following this same property, right? Next what it becomes? Log z upon log x, right? Similarly, you have log x upon log y, and then you have 1, and then you have log z upon log y, right? So you have log z upon log y, right? Then is log x to the base z, so it is nothing but equal to log x upon log z. That means whatever the base is there, that will come in the denominator, right? Then is log y to the base z, so log y upon log z, and last but not the least is 1, and you have this everything in the form of what? In the form of determinant. So let's just modify it a bit. It has to be in the form of determinant. Let's enclose in the form of determinant, and this is equal to that. Now when you have numerator also, you have denominator also. Let's see, does the question change? You see log x both in the denominator. You see log y both in the denominator. You see log z both in the denominator. That means what? That means you can actually multiply the first row by log x. If you multiply the first row by log x, here you get log x. Then log y into log x will be there, out of which log x gets cancelled. So what I do is, I do r1 such that I multiply log x with r1. Similarly, I do r2 such that I multiply the row 2 with log y into row 2. Similarly, what I have is, in row 3 I have log z. So row 3 should be log z multiplied by row 3. Now what happens when I follow this thing? I see that log x will be there outside, 1 by log x, log y, and last but not the least but log z. And then inside what you have is, inside what you have a determinant. 1 into log x will become log x, then you have log y, and then you have log z. I hope this makes sense, right? Similarly, here when you multiply by log y, so log y, you see row 2 multiply by log y, this get cancelled, it is again log x, log y, log z. Last but not the least, again the same thing happens, it is log x, log y, log z. Now we know a simple and crisp property of determinant, that if any 2 rows in the determinant are identical, the whole value is actually 0. Here not even 2 rows but all the 3 rows are actually identical. So the value is what? It is 0. And if it is 0, if the value of determinant is 0, 0 multiplied by anything or divided by anything will give me what? 0, until and unless these things are not 0. So actually my value of this question or the value of the determinant is 0, and it is already given that these are positive numbers. That means it is not 0, right? So these are not 0, you are not dividing by 0, you are multiplying by 1 and dividing by something else which is positive, so the value is 0.